What is bipolar junction transistor, BJT, and how does it works? A bipolar junction transistor, BJT, is a type of transistor that uses both electrons and holes as charge carriers. It is a three-layer, three-terminal semiconductor device used for amplification and switching applications. Structure of a bipolar junction transistor, BJT. A bipolar junction transistor, BJT, is made up of three semiconductor layers, forming two p-n junctions. The structure consists of three main regions. Emitter, heavily doped to inject a large number of charge carriers, electrons in NPN, holes in PNP. Its function is to supply charge carriers for conduction. The emitter is always connected forward biased with respect to the base. Base B, very thin and lightly doped compared to the other two regions, controls the number of charge carriers passing from the emitter to the collector. A small current in the base allows a larger current to flow from emitter to collector. Collector C, moderately doped and larger in size to collect the charge carriers from the emitter. It is always connected reverse biased with respect to the base. The collector region dissipates most of the power, so it is usually larger to handle heat dissipation. Types of BJT structures. There are two types of BJTs based on the arrangement of semiconductor layers. NPN transistor. Layers. N-type, emitter, P-type, base, N-type, collector. Current flows from collector to emitter, conventional current flow. Electrons are the majority charge carriers. PNP transistor. Layers. P-type, emitter, N-type, base, P-type, collector. Current flows from emitter to collector. Holes are the majority charge carriers. Symbolic representation of BJT. Each BJT type has a distinct circuit symbol. NPN transistor. The arrow on the emitter points outward, showing current flow out of the emitter. PNP transistor. The arrow on the emitter points inward, showing current flow into the emitter. How a bipolar junction transistor, BJT, works. A bipolar junction transistor, BJT, operates by controlling the flow of charge carriers, electrons and holes, between the emitter, base, and collector terminals. The transistor works based on the behavior of two p-n junctions and can operate in three different modes. Basic working principle. A small current at the base controls a larger current flowing from the collector to the emitter. The BJT functions as an amplifier or switch depending on its operating region. Step-by-step working of NPN BJT, common emitter configuration. 1. Applying bias voltage. The base emitter, B, junction is forward biased. Base is at a higher potential than emitter. The base collector, BC, junction is reverse biased. Collector is at a higher potential than base. 2. Charge carrier injection. The emitter is heavily doped, meaning it has a high concentration of electrons in NPN BJT. When the base emitter junction is forward biased, electrons move from the emitter into the base. The base is thin and lightly doped, so only a few electrons recombine with holes. 3. Carrier diffusion to the collector. Most of the electrons from the emitter diffuse into the collector due to the electric field across the reverse-biased base collector junction. The collector current, I_C, is much larger than the base current, I_B. 4. Current amplification. The small base current I_B controls a much larger collector current I_C. The current gain of the transistor is given by beta equals I_C/_B, where beta typically ranges from 20 to 1000. The total emitter current is I_E equals I_B plus I_C. Modes of BJT operation. A BJT can operate in different regions depending on the applied voltages. Active mode, amplification. B junction, forward biased. BC junction, reverse biased. BJT works as an amplifier, allowing current control. Used in analog circuits, amplifiers, oscillators, etc. Cutoff mode, OFF state. Both B and BC junctions are reverse biased. No current flows, I_C is almost equal to 0. BJT acts as an open switch. Used in digital circuits, logic gates, microcontrollers, etc. Saturation mode, on state. Both B and BC junctions are forward biased. Maximum current flows from collector to emitter. BJT acts as a closed switch. Used in switching applications, relays, motor drivers, etc. PNP transistor working. The working principle is similar to the NPN transistor, but holes are the majority charge carriers. Current flows from emitter to collector. The base is at a lower voltage than the emitter. Summary. A small base current, I_B, controls a larger collector current, I_C. The transistor can operate as an amplifier, active mode, or switch, cutoff/saturation mode. NPN and PNP transistors have opposite current flow directions, but follow the same working principles. Modes of operation of a bipolar junction transistor, BJT. A bipolar junction transistor, BJT, operates in different modes depending on the biasing of its two PN junctions. Base-Emitter, B junction. Base collector, BC junction. The transistor has three terminals. Emitter, base B, collector C. 1. Active mode, amplification mode. B junction, forward biased. BC junction, reverse biased. Current flows, emitter, collector, and PN, or collector, emitter, PNP. Small blue diamond purpose, used for amplification, signal processing, analog circuits. Small blue diamond current relation equals beta I C equals beta I B, where beta is the current gain, typically 20 to 1000. 2. Cutoff mode, OFF state. B junction, reverse biased. BC junction, reverse biased. No significant current flows. I_C is almost equal to 0. I_B is almost equal to 0. Small blue diamond purpose, used as a switch in digital circuits, logic gates, microcontrollers. Small blue diamond effect. The transistor acts as an open switch, off state. 3. Saturation mode, on state. B junction, forward biased. BC junction, forward biased. Maximum current flows from collector to emitter. Small blue diamond purpose, used as a switch in circuits, transistors in relays, motor drivers, etc. Small blue diamond effect. The transistor acts as a closed switch, on state. Small blue diamond condition. V C is low, 0.2 V for silicon BJTs. 4. Reverse active mode, reverse amplification. B junction, reverse biased. BC junction, forward biased. Current flows in the reverse direction, collector, emitter. Small blue diamond purpose, rarely used in practical circuits. Small blue diamond effect. The transistor operates with much lower gain. Beta is very small. Summary of BJT modes. Mode B junction, BC junction current flow application. Active mode, forward reverse emitter, collector amplification. Cutoff mode, reverse, no current, OFF switch. Saturation mode, forward maximum current on switch. Reverse active mode, reverse forward collector, emitter rarely used. Applications of bipolar junction transistor, BJT. Bipolar junction transistors, BJTs, are widely used in both analog and digital circuits for amplification, switching, and signal processing. Below are some key applications. 1. Amplification applications. BJTs are commonly used in amplifier circuits to boost weak signals. Small blue diamond audio amplifiers, used in radios, microphones, and speaker systems. Small blue diamond RF amplifiers, found in communication systems, TV, mobile networks, etc. Small blue diamond operational amplifiers, used in instrumentation and control systems. 2. Switching applications. BJTs act as electronic switches in digital and power circuits. Small blue diamond logic circuits, used in microcontrollers, processors, and TTL logic gates. Small blue diamond relay drivers, controls high-power relays with low-power signals. Small blue diamond motor controllers, switches and regulates motor speed in robotics and automation. Small blue diamond LED drivers, controls LED brightness in displays and lighting circuits. 3. Oscillators and signal generation. BJTs are used in circuits that generate periodic signals. Small blue diamond oscillators generate clock signals in communication and microprocessor systems. Small blue diamond multivibrators, used in waveform generation, e.g., square wave, pulse circuits. Small blue diamond radio frequency circuits, used in AM/FM transmitters and receivers. 4. Voltage regulation and power control. BJTs help regulate voltage and current in power management systems. Small blue diamond voltage regulators, used in power supplies to provide stable voltage output. Small blue diamond current regulation maintains a constant current flow in circuits. Small blue diamond power amplifiers used in high-power applications like audio systems and RF transmission. 5. Sensors and signal processing. BJTs are used in various sensor circuits for signal conditioning. Small blue diamond temperature sensors, used in industrial and medical applications. Small blue diamond light sensors, LDR circuits, control street lights and automatic brightness systems. Small blue diamond touch sensors, used in security and automation systems. 6. Communication systems. BJTs play a crucial role in modern communication technology. Small blue diamond radio transmission and reception, used in AM/FM radios and mobile communication. Small blue diamond modulation circuits, used in frequency modulation, FM, and amplitude modulation, AM. Small blue diamond RF power amplifiers, boosts signal strength in broadcasting stations. 7. Computing and digital electronics. BJTs were widely used in early computers and are still found in digital circuits. Small blue diamond TTL logic gates, used in early computer logic circuits. Small blue diamond memory storage devices, used in SRAM, static RAM, and early microprocessor designs. Small blue diamond microcontrollers and processors, found in embedded systems and automation. Conclusion: BJTs remain an essential component in electronics, especially for amplification, switching, power control, and signal processing. While MOSFETs have replaced BJTs in many modern applications, BJTs are still preferred in low-power and high-frequency circuits.